Okay, good morning, Professor David De Los Reyes. Okay, my topic for this morning will be algebra, and this will now be lesson number six. Lesson number six, and the title of the subject matter, it's a continuation of the fundamental operations. We are done with the addition, subtraction, multiplication, and division, even the order of operation. So we can now proceed with the next fundamental operation. As an additional, the topic will be exponents and roots. Exponent and roots. Oh, this is a familiar subject matter under the SAT and the CAT exam. Okay, let's proceed. Don't be afraid with exponents and roots. They are just what you call this, it's the reverse thing of the other. For exponent, if we try to define what is exponent, it is a way of writing repeated factors. If we try to, what you call this, express a number as a product of similar factors, we call those one, it falls under exponent. It will be, the form will be something like this, that is, a raised to n will be equal to the product of a times a times a dot times a, where n could take any value. It could be from 1 to maybe infinity, something like that. That's why I place it here. These factors on the right is actually the n factors of a. Okay? An example of this will be this one. But before I proceed with this one, I will try to discuss first what's the, what they call this, terms inside an exponential expression, because this one here is considered to be exponential expression. Exponential. Expression. Okay. Exponential expression or equation, it's the same, right? So a to the n will be the product of the product of a times a times a times a, where n could take any value from, it will not be start with 1, it will start with 2, maybe up to infinity, something like that. Where the value of n will be the exponent. So there's a, what you call this, a limit on this one. N will not be equal to 0 or n will not be equal to 1, something like that. And a will be the base. So we call this one the base, and n will be the exponent. Exponent, that's why our title is exponent, right? So if you got to see a number e raised to n, that falls under the exponential expression or exponential equation, where e to the n is actually the exponential expression. This one here. We term this one, or we call this one, exponential expression or exponential equation. An example of this, so we could visualize what is an exponential expression. If I will write 2 raised to the 4th power, okay, if we try to expand this one, the meaning of this is that this 2 here should be multiplied by itself 4 times. That's why this is 4, right? So this 1, 2, 3, 4. So if we try to expand 2 raised to the 4th power, it will be the base multiplied by itself, and n here will be equal to 4. So this will be 1, 2, 3, 4. So the meaning of this is that we will take the base, then multiply it by itself 4 times. So if we try to simplify, it's just an easy matter for this example, right? 2 times 2 will be 4, 2 times 2 will be 4, and 4 times 4 will be 16. So meaning 2 raised to the 4th power will be equal to 16. So what's the significance of this example? The significance of this example is just this portion here. right? It is similar to this. That is a raised to n will be the product of a times a times a that up to it depends on the value of n. But for this given example, so this value of n here is variable, right? So for the given example, the value of n is actually equal to 4. Oh, that's an equivalent of the so-called exponential expression. At least we now know what is an exponential expression or equation. There should be a base and there should be a power. Okay? Okay, I will try to discuss one important thing under the so-called exponential expression. One that is critical under exponential expression is that a negative number raised to n, where n is an odd number. Odd number. Okay? The value of the simplification should have a negative value. Right? That's very critical. An example of this, a negative 2 raised to the third power, where 3 is odd, right? But the value, the sign of the base is actually negative. So the meaning of this is that we should multiply the base by itself 3 times. So this is negative 2 times negative 2 times negative 2. Then try to perform the operation. Let us see if it's really negative, the sign of the resulting result. A negative 2 times a negative 2 will be a plus 4. Under the fundamental operation signs of multiplication, a minus and a minus will be plus, right? So a minus 2 times a minus 2 will be a plus 4 times a minus 2. And a plus 4 times a minus 2. A plus and a minus will be a minus 8. Right? So meaning to say, a negative number raised to an odd number, the resulting sign of the result will be a negative number, negative value. This is negative. That's the meaning of this. Try to remember that one because it's very critical in the simplifications of problems under algebra. Okay, I will try to check my color. Right? Next one, number 2. A negative number raised to n, where n is an even number. Even number meaning it is divisible by 2. Odd number, it's not divisible by 2. It's a decimal thing that will come out. So it is an odd number. For even number, the exponent here will, if we try to divide it by 2, it will be an even number, right? So under this rule here, a negative number raised to a power n, where n is an even number, the overall sign of the resulting result will be a positive value. Okay? I try to emphasize this one because later on in the simplifications of problems under algebra, there are problems wherein we try to neglect this negative sign here when we are raising to power. Okay, so an example of this number 2 here, it will be a negative 3 raised to the 4th power. So as you see, the power in here now will be an even number. So if we try to expand this one using this expression here, it will be the base multiplied by itself, and it depends on the power of n, and the power of n for the meantime is 4. So this will be a negative 3 times negative 3 times negative 3 times negative 3. This 1, 2, 3, 4. Okay, by following this. So if we try to simplify this one, a negative 3 times a negative 3, we pass by this one and lesson number 3 or 4 maybe. A negative and a negative will be a positive, so this will be plus 9. The next to negative 3, a negative 3 times a negative 3 will be a plus 9 also. A negative and a negative will be a positive, so this is plus 9. So a plus 9 times a plus 9 will be a plus, and a plus under multiplication will be a plus. So the overall sign is plus, and the numerical value of the number will be 81. So as you can see it, the sign is actually plus. Right? So this is correct. This is correct. Try to remember this two here. A negative number raised to an odd number will be a negative value, and a negative number raised to an even number will be a positive value. Okay, that's for exponents. Because on the next lessons, maybe on lesson number 7, we try to bring out the laws of exponent. Because this is just one of the fundamental expressions under exponent. And there are laws of exponent. Okay. Okay, the next topic will be roots. How to get the roots of numbers. Roots may be, there are many types of roots. If you take the square root, just this symbol here is a radical sign, right? Without these two here, okay, we call that square root. But under the radical sign, this is 3, this should be cube root. If under the radical sign, this is 4, this should be fourth root. Okay? So this is a radical sign. As always, under square root, we don't write the 2. If you only see a radical sign, it is understood to be square root. Right? If there is a 3, it's not square root, it should be cube root. If there is a 4 here, it should be fourth root. Okay? Let's try to bring out the formula and how to take the root of any number. Initially, under exponent, this is our equation. Okay? I now try to bring out two variables, x and y, right? So we could see the difference of the number from the left and side, left and right. This is x and this is y and this is n. Under the exponential expression, y can be written as x to the n, meaning this is the right hand side, y, the overall product of all of this. And the right hand side is actually e to the n. I just replace a here by x now for the meantime. Okay, where n is an exponent and x is actually the nth root, the root we are finding. It is the root, nth root. It could be square root, cube root, fourth root, or fifth root. Because this is a general equation, right? So if we try to compute for x, for the nth root, we go back to this. Okay? We go back to this. So I just rewrite it. Okay? Then I will try to raise both sides of the equation to 1 over n. Because we are to compute for x, right? Without the n. So we must have to eliminate the n. So to eliminate the n, we must have to raise both sides of the equation by 1 over n. So y raised to 1 over n will be y raised to 1 over n. And the right hand side will be x raised to n times 1 over n. The product of n times 1 over n. N cancels, so this should be equal to 1. So after raising both sides of the equation by 1 over n, the exponent, that's why our topic is exponent. The exponent of x now will be 1, okay, or just simply x. X or x to the 1 is the same. If the power exponent is 1, we don't write it. So y to the n now will be equal to x. Okay, transposing, changing locations, x now will be equal to y raised to 1 over n. So the formula on how to take the root of any number, it should be a positive number, positive real number. Because if it's a negative real number, okay, we could not take the square root. We must have to introduce the complex thing. And that's another topic, right? So in general now, if we are given y equal to x to the n, to find for x, x should be equal to y raised to 1 over n. Okay? it's just exponential is just the reverse of taking the root. Okay, so this one emanates from the exponential expression. Okay, we do some algebraic manipulation here by raising both sides of the equation to 1 over n, so we could compute for x. Okay, so x in general is actually y raised to 1 over n. So in here, x is equal to y to 1 over n, right? So if we are taking the square root, this should be 2. Okay, raised to the 1 half. If we are taking the cube root, this will be raised to the 1/3. If we are taking the fourth root, this should be raised to the 4th. So in general, x should be equal to y raised to 1 over n. Okay? An example of this, 25 can be written as 5 raised to the second power. Because 5 to the second power is actually the product of 5 times 5, right? It is this equation here. And if we try, if the problem is asking for the square root of 25, meaning the square root of this 25, you go back to this equation here, raise both sides of the equation to the 1 half. So 25 to the 1 half is the square root of 25, and this should be equal to, for the right hand side, these two here cancel with this. So the power of 5 now, okay, will be 1. So meaning the square root of 25 is 5. As simple as that, like that. Okay? It's just a reverse operation because we are given an exponential expression. Okay, and the problem is asking for the value of the one inside the quantity. To compute for the value inside the quantity, raise both sides of the equation to the 1 half because the problem is asking for the square root of 25. So 25, the square root will be the square root of 25, and 5 square, the square root or raised to the 1 half, these two here cancel with this. So the square root of 25 will be 5. That's it. As simple as like that. Okay? So what I have discussed for this morning is actually just the concept of exponents and how to take the value of roots. The next time around, I will be presenting example problems and how to evaluate problems under exponents and how to evaluate value of roots. That will be our next lesson maybe. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes. If you want to subscribe to my channel is at youtube.com/@ProfDavidJ De Los Reyes. And if you want to share it, please click share. Good morning from Los Angeles.